So this problem is similar in some ways to the last level 3 problem. So we read this right here. First step, as always, is we're going to annotate the problem. So what are we solving for? Solving for acceleration. What are we given? Well, you see the 75 kilograms is a mass. You see two forces because two numbers have newtons with them. So 735 is the force of gravity or weight. So that's what it explicitly calls it. And then it says you're experiencing an air resistance. So that is F air, 300 newtons. Next, we're going to draw a diagram. We have our 75 kilogram mass. That's me, Mr. Painter. I have my weight going down. I have my air resistance going up. I'm falling, accelerating down. I have step 3. I write my equation. Net force equals mass times acceleration. And I find my net force. So an important thing here is that because the acceleration is in the vertical direction, I'm moving in the vertical direction. And so when we solve for the net force, we're paying attention to the vertical direction, not the horizontal. So 300 minus 735, and that's going to equal MA. So I'm going to substitute those numbers. Notice that my A stays an A because I don't know what it is, but I substitute 75 kilograms in for mass. So I'm going to simplify this expression. 300 minus 735 is a negative 435 newtons equals 75 times A. I'm going to divide out my 75 so that the acceleration is by itself. Rewriting that, negative 435 over 75 is negative 5.8 meters per second squared. Now the problem asks not only what is the acceleration, but what is the direction of acceleration. And so it's negative 5.8 meters per second squared, and it is moving down. That makes sense. If I jump out of an airplane, I fall down and accelerate down. And that ends this screencast.